Here we have AP calculus AB problem. Okay, let's go with the information. Find the values of x that give relative extrema for the function f of x equals to 3x to the fifth power negative 5 times x to the third power and determine the type. So relative extrema means a local maximum or local minimum. Okay, so for that what we have to do is we have to find the critical numbers. That is the values of x at critical points for the given function. Okay, so for that what I have to do is I have to find the first derivative of the given function. So let me write the given function as it is. It is f of x equals to 3 times x to the fifth power negative 5 times x to the third power. So when you find the first derivative f prime of x, so let's consider this one. Here the variable is multiplied by a constant. When I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is and I have to get the derivative of variable alone. So I can get the derivative of this x to the fifth power using the power law of derivative. That is, I have to bring this exponent of 5 in front of the variable and subtract 1 from the exponent. That is 5 times x to the fourth power negative. So here 5 is multiplied by the variable. Let's keep the constant 5 as it is. When I find the derivative of this x cube, what I have to do is I have to bring the exponent in front of the variable and subtract 1 from this exponent. So using the power law of derivative. So now let's do some simplification over here. 3 times 5 is 15 x to the fourth power negative 5 times 3 is 15 x to the second power. Okay, now what we can do is we can factor this expression. So we have to factor this expression. We should try to find the greatest common divisor for these two terms. So the greatest common divisor is 15 and x square for this x to the fourth power and x square. So we can factor 15 x to the second power. So when it is factored and we get the stuff inside the parenthesis x square and negative 1. Okay, now what we can do is we can equate this first derivative to 0 and solve for x to get the critical numbers. So whenever I want to get critical numbers of a function, I have to get the first derivative and I have to equate it to 0 and solve for x. And there is other way too. Let me explain that one later. Okay. So f prime of x equals to 0. That is, I equate the first derivative to 0. Then we get 15 x squared times x squared negative 1 equals to 0. Then here the product of this one and this one equals to 0. So whenever the product of two quantities equals to 0, either the first one is 0 or the second one is 0. So 15 x squared is equal to 0 or x squared negative 1 equals to 0. Okay, now let me continue the stuff over here. 15 x squared equals to 0. Okay, now to solve for x, first I have to get rid of this 15. For that I have to divide both sides by 15. So when I do so, this 15 and 15 will cancel. I'm getting x square equals to, so 0 divided by anything is still 0. Okay, now to solve for x, I have to get rid of this square. For that I have to take square root on both sides. So whenever I take square root on both sides, for one of the square roots I have to consider positive or negative sign. So usually we consider positive or negative sign for the square root which contains number inside. So this square root contains number 0 inside. Since it contains 0 inside, even if I take positive or negative sign, it won't make any effect in the problem over here. So we can ignore positive or negative sign for the square root. So here on the left side, the square root and square will cancel out. X equals to square root of 0 is still 0. Okay, now I have solved the first equation, 15x squared is equal to 0, and I got x equals to 0. Now let me take the second equation over here, that is x squared negative 1 equals to 0. So now let me add 1 to both sides and negative 1 positive 1 will cancel. I'm getting x squared equals to 1. Now to get rid of the square, I have to take square root on both sides. The same thing. So since I'm taking square root on both sides, for one of the square roots, I have to consider positive or negative sign. So that has to be considered for the square root which contains a number inside. So this is the one which contains number inside, that is 1. So we can consider positive or negative sign for this square root. So here the square root and square will cancel out. I'm getting x equals to positive or negative. So square root of 1 is just 1. So I am getting 3 values for x. X equals to negative 1, 0 and positive 1. Okay, can I consider all these 3 values as critical numbers? So before that, we have to check the domain of the given function. So the function f of x, on the right side of the function f of x, we have a polynomial. Since it is a polynomial, it is different for all real values of x. So the domain of the function f of x is all real values. So if I want to consider all these 3 values of x as critical numbers, I have to make sure these 3 values of x must be in the domain of the given function. Since the domain of the given function is all real values, so we have all these 3 values in the domain of the given function. So we can consider all the 3 values of x over here as critical numbers. Now apart from that, we have to do one more check. That is, we have to check whether there is any value of x for which f prime of x becomes undefined. So for that, we can consider this particular step of f prime of x. So here also we have a polynomial for f prime of x. So since it's a polynomial, it's defined for all real values of x. So there is no value of x for which f prime of x becomes undefined. In case there is any value of x for which f prime of x becomes undefined, so we have to consider that one also as a critical number, and also we have to make sure that value of x has to be in the domain of f of x. But here there is no value of x for which f prime of x is undefined. So we have only three critical numbers: -1, 0, and +1. Okay, now what we have to do is we have to mark these three values on the number line, real number line. So let me draw a real number line. Its left side extreme is -infinity, right side extreme is +infinity, and so we have -1, 0, and +1. Okay, so using these three numbers, -1, 0, and 1, we can split up the real number line into the intervals. The first interval is -infinity, -1, and the second one is -1, 0, and the third one is 0, +1, and the last one is 1, +infinity. Okay, now what I have to do is I have to check each of these four intervals with f prime of x. So the check what I have to make is like whether f prime of x is positive or negative in each of these four intervals. So for that we have to take a random value in each interval. Okay, now what I'm going to do is I'm going to take a random value in the first interval, -infinity, -1. So any random value can be considered. So I think -2 can be taken. So -2, we have to plug in this -2 into f prime of x, and we have to check it's positive or negative. The value doesn't matter. So when I plug in x equals to -2 over here, since it's square, and -2 the whole square will become +4. That is 15 times +4. So when I plug in -2 for this x square, it will become 4. 4 -1 is 3. So here we have 15 is positive, 4 is positive, 3 is positive. Since all the three values are positive, the product of all these three values is also positive. So when I check the first interval, -infinity, -1, so in that interval, the value of, the sign of f prime of x is positive. Okay, now let's take the second interval, that is -1, 0. So we have to take a random value in this interval. So the random value is going to be -0.5. Now we have to plug in this -0.5 for x into the first derivative, that is f prime of x. So when I plug in -0.5 for x over here, since this x is squared, so the value of -0.5 the whole square is a positive 0.25. So already this first value 15 is positive. So when I plug in x equals to -0.5 over here, so and evaluate x square, it's positive 0.25. So that is the value, the sign of this value is positive. Okay, again, when I plug in x equals to -0.5 over here, so the value of this x square will be positive 0.25. Already we have -1. So the simplification is clearly negative. So the sign of the value we have over in the parenthesis is negative. Okay, now so we have to multiply these two signs. Positive times positive is positive, positive times negative is negative. So that is in this interval -1, 0 in the second interval. So the derivative f prime of x is negative. Okay, now we can verify the third interval, that is 0, 1. Let's choose a random value over here. So we can choose a positive 0.5. Now again, we have to plug in this value 0.5 for x over here. Already we know that it is positive. The 15 is positive. We can write positive sign over here. When I plug in x equals to 0.5 over here, 0.5 the whole square is 0.25. Again, this one is also positive. When I plug in x equals to 0.5 over here, it will become 0.25. 0.25 -1 will become negative. So let me write negative over here. So positive times positive is positive, positive times negative is negative. So in the third interval 0, 1, f prime of x is negative. Okay, now let's check the fourth interval, that is 1, positive infinity. For that we have to choose a random value in the fourth interval, that is 2. Okay, now what I have to do is I have to plug in x equals to 2 into f prime of x. So it's 15. And when I plug in x equals to 2 into this x square, 2 square is 4. So when I plug in x equals to 2 over here, it's 2 square is 4, 4 -1 is 3. So here all these three numbers are positive. So the product of all these three numbers is also positive. That is in the fourth interval, f prime of x is positive. Okay, now let's consider the real number line we have over here. So let's consider three values of x, that is x equals to -1, x equals to 0, and x equals to 1. So on the left side of x equals to -1, f prime of x is positive. So that is the slope of the graph of the given function is positive on the left side of x equals to -1. And the slope of the graph of the given function is negative on the right side of x equals to -1. So that is the slope of the given graph of the given function changes its sign from positive to negative. So when the graph of the given function passes through x equals to -1. Okay, now let's sketch this. Let me sketch the graph of the given function f of x according to the stuff what we have discussed at x equals to -1. So let me discuss the graph of the given function. So this is the graph of the given function f of x. Okay, here let's consider the value of x, that is x equals to -1. On the left side of x is equal to -1, f prime of x is positive, that is the slope is positive. Since the slope is positive on the left side of x equals to -1, so the graph of the given function must be rising. And on the right side of x equals to -1, f prime of x is negative, that is the slope is negative. So the graph of the given function is falling. So clearly what point is this? It's a maximum. So that is local maximum. So clearly we have a local maximum at x equals to -1. So okay, now let me write the stuff over here. At x equals to -1, we have a local maximum. Let me write it. Okay, now let's go to the next value for x, that is x equals to 0. On the left side of x equals to 0, f prime of x is negative, the slope is negative. On the right side of x equals to 0 also, the slope is negative. Since the slope does not change its sign when the graph of the given function passes x equals to 0, there is no relative extrema at x equals to 0, so we can skip this one, and now we can move to the next value of x, that is x equals to 1. On the left side of x equals to 1, f prime of x, that is the slope is negative, and on the right side of x equals to 1, the slope is positive. So the slope of the graph of the given function changes its sign from negative to positive when the graph passes x equals 1. So there is a relative extremum over here. So now for that what we have to do is we have to sketch the graph. Okay, so here on the left side of x equals to 1, the slope is negative. That is a graph of the given function must be falling. On the right side of x equals to 1, the slope is positive, so it has to be rising. So let me sketch the graph over here. So this is a graph of f of x, and say we have the value x equals to 1. So on the left side of x equals to 1, since the slope f prime of x is negative, so the graph of the given function is falling on the left side of x equals to 1. So on the right side of x equals to 1, the slope is positive. So that is the graph of the given function must be rising. So what point is this? Clearly it's a local minimum. So that is we have local minimum at x equals to 1. Let me write the stuff over here, local minimum. For the given function f of x, we have a relative extrema for two values of x. One is x equals to -1 and other one is x equals to +1. At x equals to -1, we have local maximum. At x equals to +1, we have local minimum.